Assalamu alaikum. Welcome to lecture number 17 of the course on statistics and probability. You will recall that in the last lecture, we started the second part of the course, and that is probability theory. In the last lecture, I reviewed with you the basic concepts of set theory, and also I conveyed to you a counting rule called the rule of multiplication, which facilitates the solving of probabilistic problems. In today's lecture, we will continue with the counting rules, and I will discuss with you permutations and combinations, after which we will proceed to the further concepts. All right, let us begin the discussion with the concept of permutations. As you now see on the screen, a permutation is any ordered subset from a set of n distinct objects. For example, if we have the set A, B, then one permutation is AB and the other permutation is BA. The number of permutations of R objects selected in a definite order out of n distinct objects is denoted by the symbol NPR, and it is given by n into n minus 1 into n minus 2 and so on up to n minus r plus 1. In short, we can say that NPR is equal to n factorial over n minus r factorial. Factorials को तो आप जानते ही हैं. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. Similarly, you can define 6 factorial, 5 factorial, and so on. 1 factorial will obviously be equal to 1, and also we define 0 factorial as 1. Similarly, you can think of all the higher factorials for integers which are greater than 7. Let us consider an example to illustrate the concept of permutations. Suppose that we have a group of 4 persons, and we would like to select out of them 3 persons in such a way that one is the president, one is the secretary, and the third one the treasurer of a club. Now students, if you think about it logically, you can see that the post of the president is different from the post of the treasurer or the secretary, and so this is the case of permutations and not of combinations, which I will be discussing a short while later. इसमें अगर हम मेथोडिकली चलें तो हम देखते हैं कि जो पहली पोजीशन है, जो प्रेसिडेंट की पोस्ट है, उसके लिए वी हैव 4 ऑप्शंस. यानी ऑफ कोर्स वी आर अस्यूमिंग कि इसमें हमारा अपना पर्सनल जजमेंट कोई नहीं है, और हम ऑल पॉसिबल वेज ऑफ सेलेक्टिंग दिस कमिटी ऑफ 3 पर्सन्स, ऑल पॉसिबल वेज को हम कंसिडर कर रहे हैं. तो उस लिहाज से, जैसा मैंने अभी कहा, द फर्स्ट पोस्ट प्रेसिडेंट, इसके लिए हमारे पास 4 ऑप्शंस हैं बिकॉज वी हैव 4 पीपल. और जब एक शख्स को हमने ले लिया एज प्रेसिडेंट, तो उसके बाद जो नेक्स्ट पोस्ट है, दैट इज द सेक्रेटरी, उसके लिए हमारे पास 3 ऑप्शंस हैं आउट ऑफ द रिमेनिंग 3 पर्सन्स. जब हमने उसको भी ले लिया, तो अब ट्रेजरर की पोस्ट के लिए देयर आर ओनली 2 ऑप्शंस. वो जो बाकी 2 असहाब बचे हैं, उन्हीं में से एक को हम लेंगे. According to the multiplication rule which I discussed with you last time, if there are 4 ways of filling the first post and 3 ways of filling the second and 2 ways of filling the third, the total number of ways in which this task can be accomplished is 4 into 3 into 2, and that is equal to 24. Students, ये जो इतनी लंबी डिस्कशन मैंने आपके साथ की, the rule of permutations gives us exactly the same answer and in a very convenient manner. as I discussed with you a few minutes ago, NPR, the total number of permutations of n objects or n elements taking r at a time is equal to n factorial over n minus r factorial. In this example, n is equal to 4 and r is equal to 3. इसलिए कि 4 लोग हैं और उनमें से 3 को हम select कर रहे हैं for this club. And if I substitute these values in this formula, then as you now see on the screen, the answer is 4 factorial over 4 minus 3 factorial, and that is equal to 4 into 3 into 2, and that is 24. और अगर हम ये देखना चाहें कि ये जो 24 possible ways हैं ये क्या हैं, तो a tree diagram is the most convenient way of representing this information. As you now see on the screen, if we have a tree diagram in such a way that the first 4 branches represent the president, the next 12 represent the secretary, and the next 24 for the treasurer, then the possible ways of selecting the committee are ABC, ABD, ACB, ACD, ADB, ADC, and so on. The point to note is that a tree diagram gives us a very methodical way of representing the 24 possible situations. और ये जो methodical way है, students, actually it is very important that you do practice with a number of questions so that you are able to understand the pattern in which this thing goes. इसलिए कि अगर आप इसे methodically ना करें तो it is quite easy to get confused. लेकिन अगर आप उसको गौर से देखें और थोड़े से क्वेश्चंस आप करें और प्रैक्टिस करें तो आप देखेंगे कि it is not very difficult. It follows a pattern and you can proceed in that manner. The next thing to realize is that the formula that I just gave you, the special case of this formula is when r itself is equal to n. As you now see on the screen, in the formula of NPR, putting r equal to n, we obtain NPN is equal to n into n minus 1 into n minus 2 and so on up to 3 into 2 into 1, and that is n factorial. That is, the total number of permutations of n distinct objects taking all n at a time is equal to n factorial. आइए इस फॉर्मूले को भी एक बड़े इंटरेस्टिंग एग्जाम्पल के जरिए अंडरस्टैंड करते हैं. Suppose that there are 3 persons, yourself, your sister, and your brother, and you would like to have a photograph, लेकिन आपकी आपस में लड़ाई हो रही है कि मैंने बीच वाली कुर्सी पे बैठना है और आपके भाई कह रहे हैं कि नहीं मैंने बैठना है. तो अगर हम इसको परम्यूटेशंस के जरिए देखें तो n is equal to 3. आप 3 हैं and there are three chairs and you want to we would like to see how many different ways of seating arrangement for this photograph. According to the formula that I just presented to you, the total number of ways of permuting 3 objects or 3 individuals all at a time is equal to 3 factorial, and 3 factorial is 3 into 2 into 1, and that is 6. तो अब ये जो 6 पोजीशंस 6 मुख्तलिफ तस्वीर आप उतार सकते हैं और बेहतर है कि आप 6 की 6 उतार लें ताकि आपकी आपस में लड़ाई तो ना हो. And what are the 6 photographs that are possible? If the 3 people are Aisha, Bashir, and Dawood, the 6 photographs are Aisha, Bashir, Dawood, Aisha, Dawood, Bashir, Bashir, Aisha, Dawood, Bashir, Dawood, Aisha, Dawood, Aisha, Bashir, and Dawood, Bashir, Aisha. I hope you follow the earlier point that I made, that it is actually very systematic and you just have to go about it methodically. All the discussion that we have done up till now pertained to the case when we have n distinct objects under consideration. If we have a situation where some of the objects are not distinct, then the formula for permutations modifies in the manner that you now see on the screen. The number of permutations of n objects selected all at a time when n objects consist of n1 of one kind, n2 of a second kind, and so on up to nk of a kth kind. This number is given by n factorial over n1 factorial into n2 factorial into so on up to nk factorial. Let us consider an example to illustrate the concept. Consider the word committee. This word spells C-O-M-M-I-T-T-E, and you can notice that the 3 letters M, T, and E are. So, if I consider all these letters in this word as members of a set, then I can see easily that all the members of this set are not distinct. M is repeated, T is repeated, and same for E. Now, if I would like to permute all these letters in order to form a vast number of words, some of which, of course, many of which will be meaningless, but if my purpose is such that the meaning doesn't matter, but I am interested in forming all possible words that I can, students, I will be applying the formula that I just presented to you. As you now see on the screen, in this example, n is equal to 9 because the total number of letters in this word is 9. N1 is equal to 1 because there is only one C, N2 is 1 because there is one O, N3 is 2 because of 2 M's, N4 is 1 because of 1 I, N5 is 2 because of the fact that there are 2 T's, and N6 is equal to 2 because there are 2 E's. And if we substitute all these numbers in our formula for permutations, the total number of meaningless words from the word committee comes out to be 45360. That is 45,360. ये तो था rule of permutations. जैसा कि आपने नोट किया, any permutation is an ordered subset out of a set. The other rule is the rule of combinations, और permutations और combinations में जो बुनियादी और अहम फ़र्क है वो ये है कि in the combinations order doesn't matter. As you now see on the screen, a combination is any subset of R objects out of a set of n distinct objects, and the R objects are selected in such a way that the order does not matter. The total number of such combinations is denoted by the symbol NCR, or we write N and R in a bracket in such a way that N is written on the top and R is written on the bottom. The formula for the number of combinations of n things taking r at a time is given by n factorial over r factorial into n minus r factorial. It should be noted that NPR is equal to r factorial times NCR. In other words, every combination of r objects out of n objects generates r factorial permutations. ये जो point मैंने आपको अभी convey किया, this is quite an important point, and if you understand it properly, this gives you a better insight regarding the difference between permutations and combinations, and also regarding the relationship between the two. Let me explain this point with the help of an example. Suppose we have a group of 3 persons, A, B, and C. If we wish to select a group of 2 persons out of these 3, the 3 possible groups will be AB, AC, and BC. In other words, the total number of combinations of size 2 out of this set of size 3 is 3. If we apply the formula of NCR, that is n factorial over r factorial into n minus r factorial, putting n is equal to 3 and r is equal to 2, we get exactly the same result, and that is 3. अभी मैंने आपसे जो डिस्कशन की उसमें हम ये अस्यूम कर रहे हैं कि हमें कोई कमिटी इस तरह की नहीं बनानी कि एक शख्स प्रेसिडेंट है और दूसरा शख्स सेक्रेटरी. इट्स जस्ट अ ग्रुप ऑफ 2 persons एंड सो द ऑर्डर डजंट मैटर. और जैसे मैंने कहा कि वो 3 ग्रुप्स बन रहे हैं, एक के अंदर ए और बी हैं, दूसरे के अंदर ए और सी है, और तीसरे के अंदर बी और सी है. बट नाउ सपोज that we are interested in forming committees in such a way that one is the president and the other is the secretary. As you now see on the screen, if we want to do this kind of a job, then we can have 6 committees, and they are AB, BA, AC, CA, BC, and CB. In other words, the total number of permutations of 2 persons out of 3 is 6. But the point to note is that each of the 3 combinations mentioned earlier generates 2, in other words, 2 factorial permutations. The combination AB generates the permutations AB and BA. The combination AC generates the permutations AC and CA. And similarly, the combination BC generates the permutations BC and CB. So this is the relationship that exists between the total number of combinations that you can have and the total number of permutations that you can have from one particular set and of a particular size that you select out of it. ये जो एग्जाम्पल हमने अभी कंसिडर किया, ये तो बहुत ही छोटा सा एग्जाम्पल था. अगर आप इसको थोड़ा सा बड़ा करें and you consider the case where n is equal to 6 and r is equal to 3, तो आप देखेंगे कि कॉम्बिनेशंस की तादाद तो 20 बनती है. 6 factorial over 3 factorial into 6 minus 3 factorial. लेकिन अगर आप permutations की तादाद जानना चाहते हैं तो simply multiply this number 20 by r factorial, and that is 3 factorial, and that is 6, and we find that the number of permutations is 120. That is 6 into 20, 6 into the number of combinations. The quantity NCR is also called a binomial coefficient because of the fact that it appears in the binomial expansion of a plus b whole raised to n. As you may be already aware, a plus b whole raised to n can be written as sigma r goes from 0 to n, NCR a raised to n minus r into b raised to r. The binomial coefficient has two important properties. One, NCR is equal to NC n minus r. And number two, NC n minus r plus NCR is equal to n plus 1 CR. I would like to encourage you to practice with these formulas. आप n और r के लिए numerical values रखिए और देखिए कि ये formulas valid हैं कि नहीं. Also, there are some other very useful formulas. It is to be noted that NC0 is equal to 1 and so is NCN. Also, NC1 is equal to n and NC n minus 1 is also equal to n. Let me illustrate the concept of combinations with the help of another example. As you now see on the screen, the question that in how many ways can a person draw a hand of 5 cards from a well-shuffled ordinary deck of 52 cards. The answer to this question is also found by finding the combination, the all possible combinations of 5 cards out of 52 cards, which is given by 52 factorial over 5 factorial into 52 minus 5, and that is 47 factorial. And this comes out to be equal to 2598960. In other words, 2,598,960 ways of drawing 5 cards out of 52. Okay, we have now reviewed the basic concepts of the various kinds of rules that enable us to solve a number of probabilistic problems in a convenient manner. Now that we have done this review, let us proceed to the basic concepts that lead to the formal definitions of probability. The first concept in this regard is that of a random experiment. Experiment के लफ्ज़ से तो हम सब वाकिफ़ ही हैं. And if I were to put it formally, I would say that an experiment is a planned activity that generates a set of data. Any single performance of the experiment is called a trial, and the result of the experiment is called an outcome. ये तो हुआ experiment, लेकिन मैंने आपसे कहा कि हमारे लिए जो पहला important concept है, that is random experiment. So what do I mean by random experiment? As you now see on the screen, an experiment which produces different results even though it is repeated a large number of times under essentially similar conditions, this is called a random experiment. The tossing of a fair coin, the throwing of a balanced die, the drawing of a card out of a deck of well-shuffled cards, these are all examples of random experiments. इसलिए कि जो बुनियादी condition उसकी definition की आपके मैंने present की, that it produces different results even if it is repeated a large number of times under essentially similar conditions. ये condition इन तीनों examples में आप देख सकते हैं कि it is fulfilled. डाई को आप बार बार फेंकें और एक ही तरह से more or less आप फेंकें, but sometimes you get a 1 and sometimes you get a 6. Similarly, for the drawing of the card or the tossing of a coin. Technically speaking, a random experiment has three properties. Number one, the experiment can be repeated practically or theoretically any number of times. Number two, the experiment always has two or more possible outcomes. An experiment that has only one possible outcome, that is not a random experiment. And property number three is that the outcome of each repetition is unpredictable. It has some degree of uncertainty. ये जो एग्जाम्पल मैंने अभी आपको थोड़ी देर पहले दिए, द टॉसिंग ऑफ अ कॉइन और अ डाई or the drawing of a card out of a deck of cards, you can argue that these are not the kinds of situations that we are dealing with most of the time. So let us consider a more realistic example. Consider the process of interviewing a person. आप एक शख्स को interview कर रहे हैं और आप सिर्फ एक ही question पूछ रहे हैं, and that is, are you a smoker? Students, आप realize करें कि even this little interview, this can also be regarded as a random experiment because it fulfills the three properties that I just presented to you. The first one, that it can be repeated any number of times. Well, of course, in a large city like Lahore, Karachi or Islamabad, you can ask this question not 20 times, not 100 times, but thousands and thousands of times. This experiment can be repeated a very large number of times. And the second point, that the experiment has at least two possible outcomes. Well, it is obvious. जब आप interview करेंगे तो आपको कम से कम दो जवाब तो definitely possible हैं कि आपको मिलें. I am a smoker or I am not a smoker. And then of course you can have variations to this answer. If he is a smoker but he smokes only very seldom, he can give you that information. But at least you have these two possible answers, that I am a smoker or I am not a smoker. And the last point, extremely important point, that the outcome is unpredictable in advance. जब तक आप उसे इंटरव्यू कर नहीं लेते, उससे पहले you do not know what the answer is going to be. Is he going to tell you that he is a smoker, or is he going to make a statement otherwise? So, students, this is an example which illustrates the fact that mathematical rigorous definitions like the one that I just presented, they can also be applied in real life situations. And this is the crux of the matter and the heart of the subject of statistics. As I have been conveying to you numerous times, statistics, after all, is that mathematical science that enables you to draw conclusions about real life phenomena on the basis of evidence and data that you collect on sample basis. Closely related to the concept of the random experiment is the concept of the sample space. As you now see on the screen, a set consisting of all possible outcomes that can result from a random experiment, this can be defined as the sample space for the experiment, and it is denoted by the letter S. Each possible outcome is a member of the sample space, and it is called a sample point in that space. Let us consider a few very simple examples. Suppose we toss one single coin. The sample space of this experiment will be the set head and tail, and we assume that the coin is not going to stand on its edge or to roll away. So if it is going to land either head upward or tail upward, then it is obvious that the set of all possible outcomes consists of only these two sample points. Now, if we consider the case of tossing two coins simultaneously, then of course the sample space will be a bit more complex, and as you now see on the screen, in this case the sample space will contain 4 sample points, and these are head-head, head-tail, tail-head, and tail-tail. Clearly, S is the Cartesian product A cross A, where A is the set head-tail. बिल्कुल इसी तरह से, if I toss one single die, the sample space will consist of 6 elements, 1, 2, 3, 4, 5 and 6. But if I toss a pair of dice, the sample space will consist of the Cartesian product A cross A, where A is the set 1, 2, 3, 4, 5 and 6. And the Cartesian product A cross A will consist of 36 elements that you now see on the screen: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, and so on. The next concept is that of events. Any subset of a sample space is an event. Now, the subset can consist of just one sample point, or it can be a combination of sample points, and accordingly we have the distinction between what we call a simple event and the one that is called a compound event. For example, as you now see on the screen, the occurrence of a 6 when a die is thrown is a simple event, while the occurrence of a sum of 10 when a pair of dice is thrown is a compound event, the reason being that it can be decomposed into 3 simple events: 4, 6, 5, 5 and 6, 4. जब हम sum of 10 की बात करते हैं, तब ये तीनों outcomes एक set form करते हैं: 4, 6, 5, 5 and 6, 4. As you can see, the sum is 10 for any one of them, and since this set consists of these 3 ordered pairs, hence it is a compound event. Students, the next concept, and a very important concept, is the concept of the occurrence of an event in a real life situation when we are performing a random experiment. As you now see on the screen, an event A is said to occur if and only if the outcome of the experiment corresponds to some element of A. For example, if we toss a die and we are interested in the occurrence of an even number, if any of the 3 numbers 2, 4 or 6 occurs, we say that the event of our interest has occurred. इस डिस्कशन के अंदर स्टूडेंट्स जो पॉइंट है वो ये है कि इवन नंबर की अगर हम बात कर रहे हैं तो जाहिर है कि 2 या 4 या 6 इनमें से कोई भी नंबर अगर आ जाए तो इवन नंबर तो अकर हो गया ना। और जाहिर है कि जब आप डाई को टॉस करेंगे तो ये तीनों के तीनों नंबर बैक वक्त तो अकर नहीं हो जाएंगे. You will either get a 2 or a 4 or a 6. So the point to understand is that when we represent an event by means of a set, उस set के अंदर तो हम वो सारे outcomes लिख देंगे 2, 4, 6. लेकिन जब in reality आप वो experiment करेंगे तो उन तीनों में से या उन सब में से सिर्फ एक actually occur करेगा. वो एक भी अगर अकर कर गया, हम कहेंगे that the event of our interest has occurred. The next concept is that of the complementary event. As you now see on the screen, the event not A is called the complementary event, and it is denoted by A bar or AC. For example, if we toss a coin once, then the complement of the event heads is tails. And if we toss a coin 4 times, then the complement of the event at least one head is the event no heads. The event at least one head, of course, contains the 3 ordered pairs, head head, head tail, and tail head. But the complementary event no heads is the 4th outcome of the sample space, and that is tail tail. I hope that it is clear to you that the complementary event and the original event, they are disjoint and they do not overlap. इसलिए कि complement का तो मतलब ही ये है कि वो elements जो उस पहले event के अंदर शामिल नहीं हैं. Now, the next point to understand is that any set consisting of n elements has 2 raised to n possible subsets. And so, in the context of a sample space consisting of n sample points, we can say that it produces 2 raised to n different subsets, or in other words, events, some of which are simple, some are compound, and also one of them is the null set. For example, if a sample space consists of 3 sample points, A, B, and C, then there are 2 raised to 3, that is 8 possible subsets, and they are phi, A, B, C, AB, AC, BC, and ABC. ये जो 8 possible subsets हैं, इनमें से 2 खसूसी interest के हामिल हैं. The null set phi represents the impossible event. The reason is that it does not contain any of the elements of the sample space, and as I discussed a short while ago, एक event तो तब occur होता है जब उसके अंदर जो sample points हों उनमें से कोई occur करे. तो null set में जब कोई sample point exist ही नहीं करता, तो उस हवाले से it represents the impossible event. The other set of particular interest is the sample space itself. As you saw in this example, one of the subsets of the set ABC is the set ABC. And students, this set represents the sure event. It is called a sure event because obviously when we conduct the random experiment, it is definitely sure that one of the elements of the sample space is going to occur. All right, now that we have understood the basic concept of events, the next point that I would like to discuss with you at some length is the concept of the various types of events that we may encounter when we conduct a random experiment. These are the mutually exclusive events, exhaustive events, and equally likely events. I will discuss them with you at length in the next lecture. At this point in time, I will summarize the idea by giving you the very basic definitions of the three concepts. By mutually exclusive events, students, we mean those events which cannot occur at the same time. In other words, they exclude each other. For example, if I toss a die, I will either get an odd number or an even number. It is not possible that I get an odd number and an even number at the same time. The other concept, exhaustive events, means that if we have two or more mutually exclusive events, and if they are such that when we take their union, we obtain the entire sample space, these are called exhaustive events. In the example that I just gave you, the event odd number and the event even number, these are exhaustive because if I take the union of the two, I obtain the entire sample space 1, 3, 5, 2, 4, 6, or in other words 1, 2, 3, 4, 5 and 6. The last concept at this point is the concept of equally likely events. For example, if I am tossing a coin which is perfect, it is absolutely symmetric, well made, then it is obvious that we can say that when I will toss it, the chances of getting a head are exactly the same as the chances of getting a tail. In other words, head and tail are equally likely to occur. As I said earlier, I will be discussing these concepts with you in a little bit of detail in the next lecture. In the meantime, I hope that you will enjoy studying the basic concepts of probability, and my best wishes to you. Until next time, Allah Hafiz.